Hey, welcome back to Math with Patrick and Quill. Today is October 30th, and we're solving problem 303 from the Daily Epsilon calendar. And today, we should show why the answer is 30, because that's today's date. So we need to find the number of rectangles that can be formed using the integer lattice defined by these inequalities. A lattice is just a grid, and so it looks like we have x is equal to 0, 1, or 2. I'm kind of thinking about this right here as like the origin. And then y is equal to 0, 1, 2, 3, or 4. And the lattice suggests that we have all of these points in a grid shape. And we just need to figure out how many rectangles we can make in this grid. And one thing we could do is just kind of count them up in like a specific way, or a strategic way rather. Here, I'm thinking that let's just say we decide that this is going to be one of the points in a rectangle. Then we could just kind of figure out how many different rectangles we could draw. And that first one I drew is a square, but squares are also rectangles. And so it looks like I have 4 options here, and then I have 4 options kind of going across this whole lattice like that. And so overall, I have 8, or 4 times 2, rectangles kind of coming out from this bottom left point. And so if I start thinking about other points like this one, I shouldn't count this rectangle, or square again, because I already did. And so using this strategy of just strategically counting, I'm just going to make sure that I'm not double counting anything, but I'm also counting everything. So here I'm just going to count upwards, and that's going to just be my strategy for here, where I find 3 rectangles like this, and then 3 rectangles across. And of course, some of them are squares, but squares are rectangles. So here I had 3 times 2, because I have like 3 going up, and then I have a pair for each of those 3 kind of going across. And so maybe it would make sense that this point will have 2 times 2, or 1, 2, 3, 4 rectangles coming off of that one. And then this one will have 1 times 2 rectangles, just this one and that one. Again, because if I go downwards, I'll be counting a rectangle that I've already counted. And I think the next 4 points to check are these ones right here, because I could start my rectangle somewhere in the middle of this lattice. And looking at the bottom one, I do have 1, 2, 3, 4 different rectangles that I haven't considered yet. And then we're going to have 3 coming off of this point, and then it'll be 2, and then 1. So we have 4, 3, 2, and then 1 rectangles coming off of those points. And none of the others are going to form rectangles because, again, I'm kind of counting up in a way. So if I start with this point, there's going to be no other point above it for me to make a rectangle with. And then likewise, I was also kind of counting out to the right. So if I try to define this as like my starting point, there's no point on the right for me to form a rectangle with. So these are all of the possible rectangles. I've counted them all, and I haven't double counted any. Here, 4 plus 3 plus 2 plus 1 is just 10. And then on the left side, I do have another 10, and then just times 2. It's kind of like I have 2 times, and then 4 plus 3 plus 2 plus 1, which is just 20. So overall, we do have 30 rectangles in our diagram. One other way we could solve this, I just want to show it before we end the video, is that we could start with that lattice again. It's 3 by 5. And instead of just kind of counting each individual rectangle, we could use counting principles and essentially multiply and divide our way to our final answer. Hopefully, we will still get 30 with the other strategy. The first thing that we could do here with this kind of counting principles idea is think, okay, what defines a rectangle? If I choose a point here and say a point here, that's enough to define a rectangle like this. Though if I pick, say, a point here and a point here, I'm not sure if I'm talking about this rectangle here or that rectangle right there. So with this kind of counting strategy, I want to define a rectangle by picking diagonal corners, because then it defines where that rectangle should be. And on the right side, I'll just kind of keep track of how many options I have for my steps. Like for the first one, I could pick reasonably any point on this grid. So I do have 15 options for my first choice. Let's just say, for example, it's this one. Could have been any. Now I do want to pick a point diagonal from this one. So all of these points are now no longer ones that I can pick to define a rectangle uniquely. And so it looks like I have 6 plus 2 or 8 more points that I can choose. And this will be true actually for any starting point. We could try to pick a different one. Maybe we can pick something in the middle just to see if that's any different. And then I do rule out these 5 and then those 3, although we are double counting this one in the middle. But anyways, we still do have 1, 2, 3, 4, and then 8 points to choose from. So after we pick a point, then we can pick another, and there were 8 possibilities for where that other point could go. And now I've defined a rectangle. However, if we multiply these, we're not going to get the number 30. This like 15 times 8 is much bigger than 30. And so the one extra thing to consider is that for this particular rectangle, with my strategy, there's actually 4 different ways I could have ended on this rectangle. I could have started in the top left and chosen the bottom right. Could have started in the top right, then chosen the bottom left. And essentially each of these 4 points that make up the corners of my rectangle could have been a valid starting point. And so I do want to divide by 4. And what that's going to do is it's just going to make sure that I'm not quadruple counting every rectangle. And this is 30, right? We can think 8 divided by 4 is just 2. And then 2 times 15 is 30. So using this kind of like counting strategy, we have 15 options for the first point. We can rule out all of these. We have 8 options for the next. Let's just pick that one. And then this rectangle that we're forming could have been formed by 4 other ways. You know, we could have started here, 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 and then or here, which we did. And so, yeah, this or these are 2 strategies to confirm that the answer is 30. And either way, we're done. So thanks for coming along, and I'll see you tomorrow. Bye.